Okay, so recall yesterday that we were solving a problem for a plane. If I were to shift it up in the direction of the normal by 1 unit, there's a certain way to derive the formula, correct? We use the magic triangle. How do we find the magic triangle? Well, we took a look at the planes and we know that the normal will pass through them all the same. If I can find one point here and find one point there, any 2 points on the plane, then I have myself magic triangle. Aha. Right? And we know that the normal is easy to find, it's given in the equation. The point on plane 1 is easy, but this one is a little bit difficult. So for example, we know the normal and we can know a point, right? This plus this plus this needs to equal 1. So I like to just give it a name A. Okay. Okay, we're calling this plane 1. Then, because the same normal passes through, I know that the left-hand side will be the same. Now, the only thing I don't know is the right-hand side, so let's call it C. Right? And again, if I want the point that lies on plane 2 is over here. X plus y plus z must equals to C. So very simply, let me just write it like this. And what do we have? We are given that this is 1 unit. So again, we look at our magic triangle and say, what are the two vectors that we know? I know this one, and I know this one. You're going to put your finger here, and you realize that this one is the dot product. Right? Then we're just going to merge them together. If I do the dot product, let's call this A, B, and this N. Okay, this will give me the distance, which in this question is stated, right? 1 unit. So I can go ahead and solve it. Plug in all the values, how to find AB. Alright, so we take this C value and we substitute it back in the equation. There we have the equation, right? Answer. Now, well, we would like to ask a bigger question, right? Because not all questions would say that it is a 1 unit shift. What if it were a 5 unit shift? And we can also question, well, what if the normal is different, you know? They may not be so nice to give us this is a very easy plane here, right? We would like a general form. Can we generalize this? So how do we generalize? What is given here? What is given is plane 1 and the units to shift. Then you have to find plane 2. Okay. So we have 2 inputs, right? That's the two inputs. What's the output that you want? Very good. So in a case of generalization, I want an equation that can represent any possible plane ones that they can give me. And I want a representation of how many units that they can shift. Okay, now this is easy. That's the whole point of algebra, right? How many units to shift? I can just let it be. We are units. R is some real number. So it can be a positive, whole number, fraction, irrational, rational, or negative. I don't care. It can be any units. And then the equation of plane 1. Okay. A, B, C, D are all real numbers. Okay. So let's go through the same thought flow. Again, what's the strategy? A, B. I want to take 2 points. One A from plane 1, one is B from plane 2. Right? So let's look at plane 1 first. We're doing exactly the same steps. If you have to refer, you can rewind back, run through the exact same steps. Now instead of using specific numbers, like this is a specific plane equation and a specific unit, now I'm just replacing all of them with algebra, right? Just to cover the number so we can replace them with any number that we wish. Okay, exactly the same steps. Now we have to question ourselves, what would lie on plane 1? I know I can always put a 0, 0 here. So I need A times something equals to D. Well, I can just manipulate that out by creating happy cancellation, right? Okay, you can pause to take some time to understand. Okay, and then as for plane 2, so it has the same normal, right? Therefore, we have equals to, now I can't use the same D because I doubt that they are the same. Most likely they're not. Okay, what can I call it? Well, whatever, E. Whatever you want. It's just another number. Very good. And our objective is to find this E. Right? If we can find it in terms of whatever other known inputs, then our job is done. Okay, so let me carry on with the calculation. Okay, now I want another point. Put a 0, 0. Use the same trick. A times something equals to E. So I can create this happy cancellation. Okay, so point A I have, point B I have, and the normal I have. Again, you put your fingers here and you realize this is a dot product. And we know that it is R units to shift. So let me put them all together. R units, not 1 anymore. 1 is the previous question, now it's R. Okay. Is it worthwhile bringing it out? I don't know. We'll just write it first. Okay. So that's A, B, and we have already. And then N, okay. Now I'll look at this magnitude of N, and there's really no way to simplify this. So I doubt that I actually have to open it up. I'm just gonna leave it as it is. Okay, let's see what we get here. Let's bring it over. Dot n. Okay, let's open this up. Very nice, we have a happy cancellation over here. And we are so close. Remember, what's our objective? To find E. Can we find E? Just make E the subject. Ah. What does that mean when we substitute back into the equation? Okay, there we have it. Whether you realize it or not, we have found a general formula for shifting units. If you recall, this is plane 2, right? Recall plane 1? Make the comparison. What is different? This is different. Okay, that means if you want a shortcut, one step, can you do it? So if I give you a plane ABC with a normal ABC and equals to some number, so if, for example, how do I apply this formula? So what you will get is copy paste, everything is the same, plus Rn. In this case, R is given to be 2 units over here. And we just have to find, right? Isn't it? Looking at this. So that's 4, 1, 9, 14. Square root 14. Can't simplify that. Okay. Answer. That's it. One more example. Okay. So let's do 1, 2, 3. Maybe 4. And let's say we want to shift 9. Copy paste. Again, R. This, right? This is 9 given here. This one we calculate by the coefficients. Oh, turns out to be the same. Square root 14. That's it. Just one last thing to note. Sometimes they don't say shift it, how many units in the normal, they can paraphrase it, right? Let's give this let's a 5 instead, okay? No more shift. Actually, just like this. Find the planes that are 2 units from this plane with the same normal. Okay, from here you can understand it is like this shift question, correct? Just a paraphrase. In fact, they don't have to give you the last part, and they have all rights to expect that you should know. Find the planes that are 2 units from this plane. Okay, and this may be okay, this video may be a bit longer than the stipulated time, but no worries, I'll just balance them out such that they'll all average up to 10 minutes. Okay, the timing that is fair to you lah. Okay, if one is longer, the other will be shorter. Okay, if I have Two planes. Imagine I have the bird's eye view. This one plane, I'm looking down at it, and another plane. If they intersect, can they be 2 units from each other? Maybe at some point here there are 2 units, but then here maybe 1 unit, then it gets smaller, it's inconsistent. If I assert that a plane is 2 units from each other, you are to interpret that they are parallel. And if they are parallel, it means same normal. And if it's the same normal with a certain units, it is the same as a shifting plane question. Okay, so this should be your thought flow and logical deduction. You can always rewind this and listen it to one more time. Okay, the only caveat is 2 units from this plane does not mean shift 2 units in the normal. It can also mean shift 2 units in the negative normal, which is the opposite direction. Then the original one will be sandwiched in between 2 planes. So there can be 2 answers. Can there be more than 2 planes? No, not possible already. You can just try. Use your hand, or you try use 3 pieces of paper. Correct? Can you slot in any other paper that is not already existing, the planes, such that it is also parallel and 2 units away? Impossible. Okay? So if this is the case, you just need to make your R plus minus 2. You can have a plus 2 version, you can have a minus 2 version. Plus, okay, I'll use the positive version first. This one is square root 14 minus like this, okay? So let me write it out properly. This is your answer. Okay, all from this formula, and I have proven and derived this formula, so you can use it freely. Now the question is, well, Mr. Pang, if the question comes up 5 marks in A levels and then I just do 1 step, is it allowed? Again, I tell you, you don't want Cambridge to feel cheated, you know, because this formula is not in your syllabus. What is in your syllabus is the magic triangle, which we used to solve it. Okay, so what you can do is use this formula as a checker, to check your answer. Okay, alternatively, what you can do is to present this entire formula, this derivation that I've done here, and then assert this formula, but I actually don't recommend that. What for? So the most important is to understand the thought flow of this proof, of this formula. The idea of it, again, what did we do? Find 2 points A, B, take out the normal that is given to you in a roundabout way, and then you use your magic triangle and then form the link together. Then that's it, you pretty much get the answer. Okay, so that's it for this plane shifting question. You can please take a look at the question that you have before this. Please go and try. Now, of course, this little lesson doesn't come free to you. You are to check and try this question. Okay, these are the questions. So please go and try. Okay, if not, that's all. Thank you very much.